Let's talk about margin of error when dealing with partial differentiation. Alright? Now you might have a certain value given where that value is n, the nominal value. Let's call it n. What that means is if you should ignore any errors, any changes, that is the value that you would be dealing with. Alright? For example, a certain length in meters, or a certain length in millimeters, voltage in volts, area in meter square, volume in meter cube, and so on. Alright? That's the nominal value. But sometimes you might have a case where you have n plus or minus some other value, call it E, error. Alright? So in this case, you have a certain length in millimeter plus or minus half a millimeter or 1 millimeter or 2 millimeter, whatever it is. Right? It could be that it measures 5 meters plus or minus 3 millimeters. Because when you're manufacturing, you cannot manufacture a certain, any material at all, any component that is exactly a certain value. There's always going to be some tolerance. It might be slightly larger or slightly smaller, right, than the nominal value. Alright. Now, given that n is a function of two other values, alright, say a and b. Alright, say x and y. We're accustomed to using x and y. And it's a function of x and y. What you should do is write down the formula that relates n, x, and y. Now, you have to remember that basic formula when dealing with partial derivative now. A small change in n is equal to the partial derivative of n with respect to x times a small change in x plus the partial derivative of n with respect to y times a small change in y. Right? And then you're going to use this formula. You're going to find delta n by delta x from the formula that relates n, x, and y. Oh, let me write this down. Then you find the partial derivative of n with respect to y from this formula that relates n, x, and y. You're going to multiply it by the plus or minus value of x and the plus or minus value of y. Alright? Now, you have various units of measurement: mass, length, time, and so on. Volume, current, ohms. But if the question involves angles and you're given degrees, you must convert degrees to radians. Alright? Now, of course, if you have a calculator in degree and you take the sine, cosine, or tangent of that degree, and if you convert the degree to radians and put your calculator in radian mode and calculate the sine, cosine, or tangent, you're going to get the same thing. But what will make the difference here is the plus or minus part. right? The plus or minus angle in radians. Okay, so here we have this particular formula that you see is generally used with partial derivative. It's a basic formula, you should remember it. So given that, all of that, what you're going to do in the next video in this playlist is to show examples of problems that involves partial derivatives with margins of error. Now remember, I'm going to put the link to this playlist in the description below. Alright? So I'll see you in the next video then.